Hello and welcome to the tutorial for Chapter 5, Section 2, Intro to Valuation, the Time Value of Money. In this section we'll be focusing on present value and discounting. Before we begin, let's define present value. Present value is the current value of future cash flows discounted at the appropriate discount rate. When we say discount rate, the book defines discount as the rate used to calculate the present value of some future amount. To put this into perspective, let's consider what we just went over in Section 1 of Chapter 5 when we talked about future values. We saw that when we invest an amount of money today at a given rate, that the value we realized at some point in the future was more than our initial investment because of the fact that we earned interest on our investment. We were given our initial investment and earned interest to arrive at a future value. But what would happen if we were given a future value and asked to figure out what we needed to invest today to arrive at that future value? We would be working the same problem we did in Section 1 of Chapter 5, but with one modification. We're now trying to find our present value by utilizing something known as a discount rate. Instead of taking an amount of money invested today and grossing it up, we're taking an amount to be given to us at some point in the future and discounting it down. Does that make sense? Let's first look at a single period case. Similar to what you would see at a retailer, a shirt costs $100, but is discounted to by 10%. Typically, you would say the shirt costs $90. But have you ever considered this? What if you were to take that same shirt that now costs $90 and add back 10%? You suddenly find that the shirt that originally cost $100 and was discounted 10% to arrive at the $90 value cannot be multiplied by the same 10% to get back to the $100 because 90 times 1 plus 10% is only $99 instead of $100. Instead, you have to look at the investment in today's dollars and consider what investment you must make today to arrive at a given value in the future. Relating this to an investment, we know that we must invest $90.90 today in order to have $100 1 year from now if we earn 10% on our investment. In addition to the single period case, we also have multi-period case, which consider investments made for more than one period. In this case, let's suppose you need to have $1,000 2 years from today. If you earn 7% on an investment you make today, how much do you have to invest today to make sure you have that $100 in 2 years? As we see on the timeline, we know that we will receive $1,000 at the end of 2 years, and that we will receive 7% on whatever investment we make today in year 0. This 7% is known as a discount rate because we are discounting the $1,000 we need in 2 years by 7% to arrive at the amount that currently needs to be invested. Utilizing our calculators, we know that we are looking for the present value in this case. We're given that our desire is to have $1,000 at the end of the investment period. We also know that we are investing for 2 years and we expect to receive 7% on whatever investment we make today. Since we are planning to make our investment today, whatever that amount might be, and not making any more payments over the time period, our payments are 0. Using these assumptions, we arrive at the present value of $873.44 by utilizing our calculators. This is the amount that we need to invest today to have $1,000 2 years from now and earning 7% on our investment. You might have noticed that your calculators yielded an answer with a negative sign in front of it. This is something that the calculator is required to do and is discussed further in the calculator tutorial. In addition to working the problem utilizing our calculators, you can also utilize table A2 in the back of your book, which is titled Present Value of $1 at the End of T Periods. This table can be used to derive the present value of a lump sum investment. To utilize this table, we have to consider the interest rate we are going to receive and the time period we are investing. In this case, we are going to receive a 7% interest rate for 2 periods. If we find 7% across the top of the table and follow it down 2 periods, we find what is known as the present value factor. This is a factor to be used against the future value. So, for example, we find that the factor to be used in this case is 0.8734. This factor is then multiplied by our future value of $1,000 to arrive at a present value of $873.40. One thing to be noted is that the present value factor will always be less than 1. This is because your factor will need to be multiplied by your future value. And it is known that if you desire to calculate present value, it will always be less than the future value, since your present value will earn interest over the amount of time it is invested to arrive at its future value. Let's consider example 5.6. You would like to buy a new automobile. You have $50,000 or so, but the car costs $68,500. If you can earn 9%, how much do you have to invest today to buy the car in 2 years? You notice in the timeline that we know that the car cost $68,500, and we plan to pay that amount for it in 2 years. We know that we're going to make some lump sum investment today, and we expect to earn 9% on that investment. Let's first consider how we work this problem on our calculators. Pause this video and take a moment to attempt this problem on your calculator and see if you can arrive at the same answer given in the table. Now let's attempt using table A2 located in the back of your book to also derive the value that we need to invest today to obtain $68,500 in 2 years. Please take a moment to pause the video and attempt this problem on your own.